Today we'll be working with fundamental trig identities and simplifying trig equations. From earlier we learned a couple of them, a couple ones being the reciprocals. And the reciprocals are pretty easy. The first one we learned about was secant of theta. And secant of theta we always said was just 1 over the cosine of theta. We also learned cosecant of theta, which was 1 over the sine of theta. And we had cotangent of theta, which was 1 over the tangent of theta. We also had a couple of our trig ones that we know, and we learned that the tangent of theta was the sine of theta over the cosine of theta, and that the cotangent of an angle is just the flip of that cosine of theta over the sine of the angle, sine of theta. And the last ones that we already learned, and this is a little harder one, are the even and odd functions. Okay? And the first one, let's talk about the evens. The even function is there's only one, and that's the cosine of theta. And what that meant was that if you have the cosine of negative theta, that's just going to equal the cosine of theta itself. And the other ones were odd. That was tangent, which means if you have tangent of negative theta, that becomes negative tangent of theta. And if you have the sine of negative theta, becomes negative sine of theta. And those were our known ones that we already have. So make sure you have those copied down. Now, today we're going to take a look at a new one here. It's the Pythagorean identities. Now this is a really big one. You will definitely be using this in calculus. Pythagorean identity comes from our right triangle in our unit circle. Remember, in the unit circle we have the radius of 1 and we have x and y. And here's some angle theta. So we would say, using Pythagorean, we would say x squared plus y squared equals 1. Now from earlier we know that x is my cosine value. So this becomes cosine of theta squared plus y is my sine value. So that becomes the sine of theta squared equals 1. Now this is how we normally write it, but we'd like to make it pretty, so we tend to put it cosine squared of theta plus sine squared of theta equals 1. And this is our first Pythagorean identity. And it is cosine squared of theta plus sine squared of theta equals 1. To get our remaining Pythagorean identities, we're going to take our cosine squared of theta plus our sine squared of theta equal to 1, and we're going to divide. Like, what happens if I divide everything by cosine squared? Well, this just becomes 1 plus tangent squared of theta equals, and 1 over cosine, of course, is secant squared. Secant squared of theta, and that's our other one. 1 plus tangent squared of theta equals secant squared of theta. And there's our second Pythagorean. And to get our third Pythagorean, same thing. We go cosine squared theta plus sine squared of theta equals 1. But this time we're going to divide by, you guess it, sine squared of theta. And this becomes cotangent squared of theta plus 1 equals cosecant squared of theta. And that's what we get here. Cotangent squared of theta plus 1 equals the cosecant squared of theta. And those are our 3 Pythagorean identities. Okay, now we can use these 3 to help us rewrite. For example, let's take a look at 1 minus sine squared of theta. Well, what would that equal? Well, it's all dealing with sine, so I'm going to be using my first one. And it says cosine squared of theta plus sine squared of theta equals 1. Well, if I subtract sine squared of theta, I get 1 minus sine squared of theta. That's going to equal cosine squared. So I can just write this as cosine squared of theta. So now this is a little bit tougher when it says cosine squared of theta minus 1. So to help us with this one, what we can do is rewrite it again as says cosine squared of theta plus sine squared of theta equals 1. So again, I want cosine squared minus theta, so minus 1. So what I'm going to do is I'm going to subtract the 1. That gives me, bring over the 1, cosine squared of theta minus 1. But if I bring the sine squared over, I get negative sine squared of theta. And that's how I could write this, negative sine squared of theta. What about cosecant squared minus cotangent squared? Well, that's going to be using my third Pythagorean identity. Cotangent squared of theta plus 1 equals cosecant squared of theta. I want to get this, so what I have to do is I'm going to bring over my cosecant squared. So I get the cotangent squared of theta minus the cosecant squared of theta, and I bring over the 1, negative 1. This is just negative 1. Now, you do have to have all three of these memorized, so please make sure you take the time to practice these and memorize those. What about 1 minus cosecant squared? Same idea. I'm going to use this one. Cotangent squared of theta plus 1 equals the cosecant squared of theta, and I want to get this, so I'm going to bring over my, let's see here, I want to get 1 minus this, so if I bring over my cosecant squared, that's going to give me my 1 minus cosecant squared of theta. So what is that going to equal? I bring over my cotangent squared. That becomes negative cotangent squared of theta. And that's what we get here, negative cotangent squared of theta. So it's just a lot of algebraic manipulation. All right, the last one, secant squared of theta minus 1. So I'm going to be using my 1 plus the tangent squared of theta equals secant squared of theta. And a lot of times I don't maybe memorize these. Remember, you just know the one, you can derive the other two. All right, but here we go. This is secant squared of theta minus 1. It just says to bring over my 1. So I get tangent squared of theta equals secant squared of theta minus 1. So this is tangent squared of theta. A lot of students tend to really like this unit because it's a lot of fun. All right, let's try this one. Tangent squared minus secant squared. So I'm starting off with 1 plus tangent squared of theta equal to secant squared of theta. I want tangent squared minus secant squared, so I bring over my secant squared. And I get tangent squared of theta minus secant squared of theta. But what to do with that 1? It's not in my problem, so what do? I bring it to the other side, becomes negative 1. And there's our answer. All right. Please make sure you take a look at these. Make sure if you have any questions. Now in part 2, we're going to take a look at some more challenging examples, so please make sure you go through the notes in part 2. Thank you.